Dear students, welcome back to another video, and in today's video we are going to learn about one of the topics of chemical equilibrium, and that is equilibrium constant and its units. So let's start the video. Okay, before moving towards equilibrium constant, I just want you to recall about the reversible reactions. I hope that you remember that reversible reactions are continuous in nature, and in such reactions the reactants are reacting together to give you products, and products are again reacting together and they are giving you back the reactant. So this is a continuous process, and one of the peculiarity of these reactions, reversible reactions, is the chemical equilibrium. Like, what is chemical equilibrium? In simple words, it means there is no net change in their amounts, the amounts of products and the amounts of reactants. So I hope that you have recalled this. So let's move quickly towards equilibrium constant. So equilibrium constant is basically represented as Kc. What is it? Let's see its definition. So equilibrium constant is a ratio of the product of concentration of products raised to the power of coefficient to the product of concentration of reactants raised to the power of coefficient, as expressed in the balanced chemical equation. So the important thing is here the balanced chemical equation. I hope that you have learned it. Now this is how you express the equilibrium constant. Okay, so we see here product of concentration of products raised to the power of coefficients. Here the power of coefficients are basically the number of moles of the products, while here the product of concentration of reactants raised to the power of coefficients. So the power of coefficients are representing the number of moles of reacting substances. So we'll clarify our concept with this reversible reaction. I hope that you've understood that this double arrow sign is representing that this reaction is reversible reaction, in which reactant A is reactant B to give you product C and D, and the number of moles are here, small a and small b for reactant A and B. These are the number of moles for them, and small c is the number of moles for product C, and small d is representing the number of moles for product D. So according to this expression of Kc, you will put them. So here the products are on the upper side while the reactants are on the lower side, while these small alphabets are representing their concentration, their number of moles. Okay, while these are representing the concentration. So this is concentration of product C, and this is the number of mole of product C. And similarly it goes with the molar concentration of product D, and this is number of moles D for this product D, and this is the reactant A, it's the molar concentration of A, and here the number of moles of reactant A, while this is the molar concentration of reactant B, and here are the numbers of moles for the reactant B. I hope that you have understood this expression for equilibrium constant. Now we'll see the units of Kc. So there are two conditions. First you'll see the case 1, when number of moles of reactants are equal to the number of moles of products. That is, when number of moles at reactant product sides are equal, then equilibrium constant will bear no unit. No unit will be there when number of moles of reactants are equal to the number of moles of products. As you can see here, 1 mole of hydrogen is reacting with 1 mole of iodine gas, and they are giving you 2 moles of hydrogen iodide gas. So you can see 1 plus 1 2, and here 2. So when you put, like, you express it like this, you are putting the product here, expressing the number of moles here and reactants here. Since nothing is here, you must have understood that this is the power 1 that you are not showing. So unit of Kc will be, it will cancel out each other and no unit will be there. Since 2 here, 1 and 1, they're cancelling out each other, so there will be no unit of Kc. In the other scenario, when number of moles of reactants and number of moles of products are unequal, so there will be a unit for Kc. You're looking here, 1 mole of nitrogen is reacting with 3 moles of hydrogen to give you 2 moles of ammonia. So you can see there are 4 moles of reactants and 2 moles of product. When you put the value in this expression like this, then you will have such condition. Okay, so you are just writing the concentration here and writing number of moles, representing them as the power. Here nitrogen is basically 1 mole of nitrogen is reacting, and here 3 moles of hydrogen are found. So when you just solve it, then you will get this unit for Kc. Since this mole, when it will multiply with this, it will get the value mole square, and dm inverse 3, it will multiply with 2. Minus 3 into 2 is minus 6. When you when you reverse them, when you just move them on the upper side, then it will be mole inverse 2 dm6. I hope that you understood it. Now we'll further clarify our concept with some examples. You know this equation for the reaction when hydrogen iodine are reacting to give you hydrogen iodide. Here the equilibrium concentration are mentioned. Okay, remember, actually the value of this Kc depends on the temperature. It depends on the temperature. So this is one of the important point that you must remember. Okay, it has no link with the initial concentration of reactant and products, but it has a relation with the temperature of the reaction. So when you put these values, like for hydrogen, the concentration is given, iodine has got its concentration, and hydrogen iodide concentration is also available. You simply represent this Kc and put the value of the molar concentration. Then you will get the equilibrium constant for this reaction as 80, and there will be no unit for this Kc, since the number of moles of reactants are cancelling with the number of moles of products, since they are equal. Now I move with example 2, in which 1 nitrogen is reacting with 3 hydrogen gas molecules, and then it is giving you 2 moles of ammonia gas. So we have mentioned here the molar concentration, the equilibrium concentrations for nitrogen, hydrogen and ammonia gas. We simply express this equilibrium constant, and we'll put the values one by one. For ammonia it is 0.113, for nitrogen it is 0.602, and for hydrogen it is 0.420. We'll express their number of moles. We'll solve them. It will be the value of Kc, equilibrium constant value will be 0.286, and its unit will be mole inverse 2 dm6. Well, I hope that you have understood it. What is equilibrium constant? How do you find out its value, and how do you put the units? Still, if you have any query, feel free to ask in the comment. If you like this video, smash the like button, hit the subscribe button. It means a lot. Thank you so much. I will see you in the next video. Take care.